So we've got an alloy rectangular member of 24 by 50. So if this is my ruler, I know that if I applied a load at the top, that it's going to bend around the thinner axis. And I'm told that my load is 1.1 in the question. I'm not given my L. And it's fixed at the bottom, and it's free, swaying about at the top. So it's stuck in the ground, or if it was a beam, it'd be like a diving board stuck in the wall. So if I start, assuming Euler's formula to hold good, what is the length of the strut? And I'm given what my E value is. So E is 180 kilonewtons per millimeter squared. So if I just start filling in what I know into this formula for my load, it's our mass times by the gravity. So that gives us 10,791 newtons, or let's say 10.8 kilonewtons. Got my E value is in kilonewtons in millimeters. And my effective length, what's my effective length? Is it just L, or is it? Yeah, it's 2L. Well done. And then in terms of my I value, I've got BD cubed over 12. So again, if you can't remember all of these formulas, they'll be in the handout that you can use. Again, it will fail about this axis where my depth is 24. So if I made D 50 or if I made D 24, you have to work with the smallest value. If you can't get in your head which is the smallest, just work out with B and D as 50 and 24 or 24 and 50. But with a D value of 24, you should get an I value of 57,600 newtons per millimeter squared. So again, that's with your D as 24. If you did put D as the 50, you'd end up with a value of 250,000, 5 times stiffer across this axis than what it is across that axis. But you don't need to know that. You just need this, again, the smallest I value. So I need to know L. What I will do is I will rearrange this formula so we end up with L. So that's the Euler formula rearranged. And then putting in my values times by my I value. Again, the biggest problem that people have is that they mix up kilonewtons with newtons and millimeters with meters. You just got to make sure they're the same. Yeah, so that's now in newtons per millimeter squared in newtons. I think I've said before, whenever you, as an engineer, you're filling out your calcs, you get to the end, you pass your calcs to another engineer, like usually a chartered engineer, they will check it quite often. They're picking up where you've missed out your converting millimetres into meters. Now note that that this is my effective length. So if I wanted to try and work out my length, so my effective length is 2L. Therefore, my L is the effective length divided by 2. So therefore, my length is 3,078 divided by 2, 1539 millimetres. That is my answer. That is the effective length. So that's the actual length of the rectangular. Now the second part of that question says, okay, so if now that you've identified the actual length of the member itself, it says, what if one end was pinned? So in terms of A, like the part afterwards, if it was fixed and pinned at the other end, my effective length is 0.7. So if my effective length is 0.7 times by the length that I've just worked out, if I put that effective length into my PCR equation, fixed at the bottom and moving around freely at the top, it could take a load of 10.8, where if you pin it at the top, making a little snake, then it'll take more load of 88.2 kilonewtons. So it can take 8 times the amount. And if you pin both sides, then you'll find that your PCR equals 43.2